In this video, we'll learn about isotopes. Isotopes are defined as atoms of the same element that have different masses. And that means is that they have the same number of protons, therefore they're the same element, but they have different numbers of neutrons, which allows them to have different masses. So these two representations of atoms are isotopes of the same element. If we look on the left, well, there are two protons. On the right, there are also two protons. So actually, both of these will be helium. The atomic number and the number of protons are going to be the same in both. However, what differs is that the mass number of the element or the atom on the left is going to be 3 because there are 3 particles in the nucleus because there are 2 protons and 1 neutron. For the atom on the right, it has 2 neutrons and it has a mass number of 4. Both of them have 2 electrons, as we can see. And so the isotope on the left is going to be called helium-3. That 3 stands for the mass number. And the element, or rather the atom on the right, is helium-4. Now, as for the isotope symbol, I'm actually going to bring in our build an atom simulation here. And what we'll do is we will make the atom on the left. And note, we've got the 2 protons, 1 neutron, and 2 electrons. Look at what we have here. Our symbol is 3/2He, 0. So what I'll do is I'll write that in, 3/2He. And since that 0 is the charge, since it's 0, I'm not going to put anything in here. It's not required that you signify that something is neutral. If there were a positive or negative charge, it would go in this corner. But now I will transform this helium into a different isotope where there are now 2 neutrons in the nucleus. And note what's changed is just that number right here. So we have 4/2He, still neutral. So that number on the top left corner is the mass number. The bottom left is the atomic number. So let's do some practice. Let's say that we've got this table to fill in, and we know our symbol for a substance is 26/12 mg. Well, the bottom left is the atomic number, and that is 12, and the atomic number is the number of protons. The number of electrons is going to be equal to the number of protons because there's no charge specified. Because there's no charge specified, we know it's going to be neutral, and there need to be an equal number of electrons as protons. Finally, the number of neutrons we can figure out just by finding the difference between the mass number, which is 26, that's the top left here, and the number of protons, which is 12. This is kind of neatly set up. 26 minus 12, that gives us 14. And I'll erase that, though, because we need this space later. All right, next, we've got this line here. Where to start? Well, if I know that there are 47 protons, I know the element is going to be Ag. So I can start here by writing in Ag. And next, maybe I should put in the number of protons as the atomic number, which is 47. That's easy enough. And I can also put that down here because this is where the 47 goes. This is where the atomic number and the number of protons goes. The mass number in the symbol is always going to be the top left, so that's my 109. And finally, I've got to figure out, well, a charge and the number of neutrons. Let's do the charge. Charge is equal to protons minus electrons. And that's actually worth noting because this will always give you the right sign. It's the positives minus the negatives. So if we have 47 positives and 46 negatives, there's overall a positive 1. 47 minus 46 is positive 1. So I'm going to put a plus here,
where the charge should go in the symbol. Finally, we do need the number of neutrons, and if I were to subtract 109 minus 47, I would get that there are 62 neutrons. And that's all on that. So I hope this video has been helpful. Feel free to leave any questions or comments in the comments section below. Thanks for watching.